So there is a physics-mathematics connection that pervades Harish-Chandra's life. And in fact, much of his math thinking seems to have been inspired by physics, which is where the connection to the Harish-Chandra Research Institution comes in, which has been conceived of as a center where physics and math sit side by side and try to do research at a very high level. What is worth repeating is Harish-Chandra belonged or was trained in this part of the country.
He was born in Kanpur and went to college in Allahabad, where he got his MSc degree. That is his association with Allahabad. And that is the reason why this institution is named Harish-Chandra Research Institute.
Someone from who's grown up in Kanpur, studied in Allahabad, and then goes on to spend a life and do research at the Institute of Advanced Study, performing at the highest level of mathematics, is, I think, a story that deserves to be so much more widely known. In fact, when I started my career as a scientist, I am so embarrassed to say I didn't know of Harish-Chandra. I mean, a professional scientist, a physicist, of course, not a mathematician, did not know it. I think that situation continues, that many of the young people aspiring to do physics or mathematics do not know of this man, because it is believed in the scientific community that after Ramanujan, Harish-Chandra was the most important Indian mathematician to have emerged. And for the students of today who are aspiring for a career in science or mathematics, the life story is so inspiring.
Harish-Chandra was a great mathematician of the 20th century, the greatest since Ramanujan. Actually, I'm willing to think of, I'm inclined to think that he was as great as Ramanujan, but that is probably something which only time can definitely confirm. He had a very good academic career. He stood first in every exam he took, but there's one interesting fact that in one physics examination he scored 100%, and that examination was corrected by Sir C.V. Raman. So his teacher was K.S. Krishnan, a renowned physicist, and on his advice he went to work with Homi Bhabha, the founder of our atomic energy program, and Bhabha sent him to work with Dirac. Dirac is a famous physics name. Harish-Chandra graduated in physics, not mathematics, and then he went to Cambridge to work with Dirac, and then Dirac himself moved to Princeton for a short visit, and he took Harish-Chandra along, and there he came into contact with a mathematician by name Chevalier, and that turned him away from physics, and he devoted his entire life to mathematics after that. There is a subject which is known as representation theory. When he started, it was considered not so interesting an area. It was in the outskirts, so to speak, of mathematics. So he brought it center stage. By the 1960s, the subject had become so important and occupied center stage of mathematics, mainly because of Harish-Chandra's work. Single-handedly he did this job. That's why everybody considers him great.
Even if the math that he did was a bit arcane, it takes time to appreciate its content, but the story behind it, of someone growing up under simple circumstances without a great advantage in life, and then by sheer dint of talent and hard work, ultimately belonging to the pantheon of great mathematicians of the century.
This is the centenary year of his birth, and we are having a conference in his honor.
It was remarkable to see the kind of respect that mathematicians all over the world have for Harish-Chandra. We are very fortunate to get a few people who knew Harish-Chandra 40 years back and are still around and active, and were so affectionate and sort of almost reverential towards the impact Harish-Chandra has had on their work.
And what we want to discuss here is Harish-Chandra's mathematics, not technical details, but how he, things like how he approached mathematics, what was his philosophy, and what in general, not about mathematics alone, but about other disciplines, general life in general, whatever you know about such things, to the extent it is related to mathematics. We can talk about, that's the kind of thing I want discussed. Go through the introduction. I am Raghunathan, retired long ago from the Tata Institute of Fundamental Research. I have other coordinates which are unimportant. So, Laurent Clausel from Paris, Orsay, right? You were?
Paris Sud, yeah.
Paris Sud. He's also retired.
And David Vaughan is a
MIT.
student of Bertram Costant and been at MIT ever since. Yeah.
Premala-Chandra, professor of physics at Rutgers, daughter of Harish-Chandra. Dinkar Ramakrishnan from Caltech, and Dragan Milicic from Utah, Parthasarthi, retired from TIFR, and Deependra Prasad, now at IIT, not retired but moved from TIFR to IIT.
IIT Bombay.
IIT Bombay, yeah. Now I'll begin with asking Premi to talk about her father. Premala-Chandra is Harish-Chandra's daughter and is a professor at Rutgers, physics professor at Rutgers University.
Thank you very much. My father really loved his work. We could always tell when things were going well because he would sing his ragas while he worked, and we knew not to disturb him. When things were not working, everything was quiet, and we definitely knew not to disturb him. Then he would often sit in a dark room listening to Beethoven for hours, hoping for some inspiration. He believed very strongly that understanding should come from within. And it was quite tough to learn from him. We had very intense discussions, not always so pleasant for me because he reminded me of what I thought I understood but didn't really. But he did teach me how to learn. My father started off in physics. He was influenced by K.S. Krishnan at Allahabad here, and he had tremendous respect for physicists. He always retained a love of physics, a reverence for physicists with deep intuition. He always said that he left physics because he did not have a sixth sense for using intuition to guide him through forests with methods that were not mathematically rigorous. I think, and this is of course just my feeling, that his style in mathematics, of what I've learned, was very much inspired by physics. At least from what he told me, he always worked on one specific favorite group, SL2R. He loved working on SL2R. He would work on this and then generalize it by induction. Now that's an approach that we in physics use a lot. We take a toy model, we take a complicated system, which we have no hope of describing everything. We ask what the minimal model is to describe the important features, then we work on that, and we hope to generalize it to the case. And so in that sense, I think my father's style, from what I understand, was very influenced by physics. I would say he was very intense. He was someone with relentlessly high standards, but which made him both inspiring and impossible. But he was never harder on anyone than he was on himself. And that's what made it all work. Thank you.
In the mathematical community, he has a reputation of being a very hard-working person.
Yes.
Was he a systematic person, allotting a certain number of hours during the day to work something, or was it random?
No. He worked, this reputation is well-deserved. He worked 7 days a week. He broke for meals, for tea. He did his yoga twice a day, and he went for walks twice a day. He was very lucky because, of course, my mother took care of everything else, including us. Okay? So he had a very rigorous schedule. However, on doctor's orders, for 6 weeks every summer, he was not allowed to work at all. And it was those times when we as children, my sister and I, really got to know him. We would go off to, he loved the mountains, he loved hiking. Ever since he went on a trip to Kashmir when he was about 14, he had a very good sense of balance, okay? He was like a mountain goat on those mountain trails, okay? And I remember one time when I was 9, we were in Glacier National Park. We explored the national parks because my parents, of course, were immigrants and they didn't know the US, so we would rent a place, we would drive somewhere, rent a place, and then go hiking all day and read plays all night, okay? So that was a time when I really got to know him. And I remember one time when we went on a walk, and my sister, I must have been about 7, and my sister was 3. My sister was on his shoulders. It was hailing, it was slippery, and there was a complete drop, and our guide just said very cheerfully, if the fall doesn't kill you, the traffic will. And there we were. And my father just kept on walking with my sister, and we were supposed to keep on walking. What choice did we have? So we did a lot of walking. We read a lot of plays. One of my father's favorite plays was Ibsen's Enemy of the People. You may know this play. It's a Norwegian play. I reread it during the pandemic. It's about a man who senses that he lives in a spa town. He senses that the local water has been corrupted in some way and people are getting sick. But the mayor, who's his brother, decides that he doesn't want to tell anyone because it would ruin their business.
There is a version by Satyajit Ray, actually.
Yes, absolutely. That was one of my father's favorite plays, so we read it over and over again. So these summers were when we really got to know him. And then you could tell he was thinking about his mathematics, but he was not allowed to write anything. And he as usual, he kept very strict to that. So he read books over the summer, usually history. And as I mentioned earlier today, he had a photographic memory, so he remembered everything that he read, or everything that we said, which was highly inconvenient. But in any case, but he had a relentless work ethic. And what's interesting is he was very much of a mental athlete. He was democratically rude. When he had an idea and people came over, he would just leave and go to a study. It didn't matter who they were. And at one stage, I was friends with a couple of the rowers. I did some rowing myself in college. And in Princeton, we have the Olympic trials for the women because we have a very nice lake. And I knew the coach and I knew a couple of the women on the crew team. And these are pretty intense people. They're trying to get to the Olympic squad, and we had the coach. And we invited them over for lunch. And my mother warned me. She told me that my father would probably show up, eat, and leave, because this wasn't really his crowd. But what really surprised us was he was talking. I mean, he resonated with their intensity. He started talking to them, wanting to know about their training, wanting to know about this and that. He was talking to the coach. We were all amazed. And it was basically because he resonated with their intensity. And their regime wasn't that different from his. So yes, he had a terrific work ethic.
Well, he obviously belongs to the pantheon of 20th century's great, but there are others in the pantheon, and maybe some of you would like to compare him to, or say how he was different from others. Each Greek god in the pantheon was different from another, so these people will also be very different from each other. Maybe if you may like to say something on that. Closer?
Actually, I don't like to compare people, so I'll pass.
Okay.
I should say that my father had tremendous respect for André
Sorry,
Weil.
it's not. I don't want you to compare. You can only say they're different, and how the difference. Two people whom you admire, say for instance, one is Harish-Chandra, another is X, and you want to say how they are different. I'm not saying you certainly cannot rate these people. That's out of the question. That's absurd to try to do that.
I should say that in our neighborhood, the work ethic was pretty strong.
Yeah.
It wasn't just my father.
Yeah, Borel.
Yeah, Borel was there. I was just saying André Weil also. So I'm just saying, I don't think you could. He had a relentless work ethic, but he had a relentless work ethic, but so did many others.
Yeah, certainly. I think Borel worked hard. I mean, I was in Building C. I have to say that when I would arrive in the morning, I often started early, like 7:30 or so. He would be already there in his office. And then when I left, and I would go for walks, I would go for tea and all these things. And later, when I would finally go home, like 6:30, he would still be there. And then sometimes my wife, my girlfriend at that time, Pat Carlton, she and I would take a walk through the woods, and we would come back about 9 o'clock, 9:30, and I would see the light on in Borrell's office. I think he worked harder, I have to say, than anyone I know. But I feel like Harish-Chandra worked with greater intensity. I think that's it. I don't know anybody who worked with the same level of intensity.
Absolutely, that's the great difference with Borrell. If you look at Borrell's bibliography, it's diverse. There are things which are new and very deep, and there are things which are easier. But Harish-Chandra just went to a given aim, different depending on the stages of his life, and relentlessly. And so, they were quite different personalities.
Roger mentioned Harishchandra's having in his files complete papers which were not published, just complete manuscripts. And the reason, as I understand it, is that he was proving the Plancherel formula. And everything that he published was aimed at this program of getting the Plancherel formula. And if he had some other very deep ideas, he had a great respect for all of mathematics. He knew that he should write this down so that it was properly recorded, but he wasn't going to waste time publishing it because it wasn't a step towards the Plancherel formula.
In fact, there is a new volume for Harish-Chandra's collected works, which has some of these manuscripts.
Right, yes.
I think V.S. Vardarajan and Ramesh Ganguly have edited this volume.
Right, yes.
And if we are lucky, this volume will be made available for this conference.
Yeah, these two papers I was mentioning about differential equations and then application to matrix coefficients, they were written in all possible details with references, with everything.
But in this collected works?
They were, they were handwritten. They appeared in collected works, but I think this was typeset by Varadarajan. And so Harish-Chandra found a different way to prove these results and just, in some sense, abandoned them. So he was surprised when I actually asked him for this. So in a way, he had an ultimate goal and kind of he was going towards this with some kind of ease. I don't know. It was clear that he knows how to proceed. I know that Borrell, when he was writing the module book, he was struggling because this was not his forte, but he wanted to write this and he was asking us questions. I think to Harish-Chandra, it was always clear where he wants to go and what he wants to prove. And one thing I kind of disagree with Roger, I mean, I was reading these papers without any help. And if you go slowly from the beginning till the end, everything was clear. All the proofs were complete.
Even though which square root of minus 1?
Yes, that's right, yeah.
I would always fix, every day I'll fix square root of -1 and then continue.
Yeah, I think he was really exact. I mean, I'm not as much an expert as some of these people, but even my most recent work, which I may talk about tomorrow, is there was a problem. I was referring to a reference, whom I won't name the author, but that it didn't fit right. There was a formula for formal degree for the representations of unitary groups and discrete series, and it didn't fit right. So then we decided to go back and read Harish's paper, and it was there, and it was correct, and it fit exactly right. It was some silly error somebody else had made, but anyway, but he was very careful. And one thing I would say is that Harish also, I found, had extensive notes on other people's works. which were not his work, and which is something he wouldn't want to work on himself sometimes. He had a lot of things, like I was telling before, Langlands' book on Eisenstein series, it made a big impression on him. I have to say, he told me essentially like it was a masterpiece, and he really had extensive notes on it. I really wish I could get my hands on it, because he explained one part of it. I saw he had a whole sheaf of papers, and he looked through them, and then he found, because we were talking about some things that happened, real numbers, the zeros or something, and he explained that, but he had very good notes, and it wasn't because he needed it for his work.
Harish-Chandra announced the regularity theorem in 1962, but Varadarajan says that he had all the ingredients of the proof, around 1956, 58, around that period itself. So I was wondering whether it reflects on the way he works. I mean, nowadays we find a lot of people saying that this is an ongoing project, things like that. But so does it reflect on the, I should not announce anything until I have a complete written proof in my hand, or is that how he?
I mean, this was definitely a different time. This
right.
Announcing things which are half proven was not a habit at that time.
I don't know if he agreed with that. He was saying that there are people, he actually asked someone at the institute, somebody said, I think it's true. So Harish raised his hand and said, what do you mean you think it's true? Is it true or not?
Borel somewhere says that he and Weil thought that Harish-Chandra was the real heir to Siegel's legacy. I wonder how your father would have reacted to that.
I can't really comment on that.
He was there too, what?
He was the true heir to Siegel's legacy, mathematical legacy. This is what Borel has written actually somewhere, that he discussed it. They discussed, Weil and he had discussed it, and they came to the conclusion he was the true heir.
Yeah,
This was perhaps in the context of Siegel thinking that Harish-Chandra was a Bourbaki.
Yeah, that's what I was going to say.
Yeah.
Like René Thom.
Because that's what.
Yes, and I think
that's a story current among mathematicians. But I've heard someone close to Siegel tell me that is not true, that it's not because he was Bourbaki that he denied him the prize. He really thought Roth's work was of higher caliber. That's what he said. And I mean, as Lang says, great mathematicians can have their own prejudices. So,
but I'm surprised at what you are saying, because, of course, perhaps all of us have read the Royal Society biographical note about Harish-Chandra by Langlands. And Langlands explains that Harish-Chandra didn't get the Fields Medal because Siegel opposed it.
Yeah.
Siegel said, so, I mean, you can't see him as a heir to Siegel. I find that very strange. Is that what you're saying?
The story actually is that Siegel said there's one Bourbaki who's already got the medal, so you cannot throw him, in his opinion, as the Bourbaki, which I think is absurd. And the other, so it can't go to a second Bourbaki.
I understand that, but he opposed it. He certainly opposed it. He opposed the Fields
He
Medal.
opposed it because he didn't want a second Bourbaki. That's the story.
But he still did. Okay. So he still did.
But that was denied by a person who knew Borel very well, and was a friend of mine. And he told me that that is not true. He really thought Roth's work was of a higher order than Harish-Chandra's, which for most of us is absurd. Anyway, but great mathematicians can also have their views, which are peculiar views on certain subjects.
In response to your question, I think my father would have been very flattered that André Weil thought well of him, because he had the greatest respect for André.
Yeah, sure.
He always talked about him in the most glowing terms.
Yeah, but I don't know if your father's style of mathematics can be compared to Siegel's style.
I'm not in a position to say.
To me, it's, whatever little I know seems very different.
That's what I would have thought from what I've heard, but
I think Harish-Chandra's style of mathematics, Premi kind of alluded to it at the beginning of her physics lecture. I think I've heard Roger Howe tell me this story, that Harish-Chandra repeated what he said was a Hindu legend, which I've never been able to find anywhere else. Roughly speaking, that God ordered the devil to go and create the world, and the devil went off for a week and tried to, I guess like going to your father's office, tried to think of how to approach this problem. And he came back after a week and said, well, could you tell me a little bit more what you have in mind? And God said, well, mostly you can do whatever you want, but there are these few things that he had this little piece of paper. These things I must have. And he said, I think it's the job of science to find out what was on that piece of paper. To understand what is fundamental.
Keep your hand out of semi-simple Lie groups.
I think this is related to the same story that one of the requests was Lefschetz principle, and then the devil said, but I want complementary series. I mean, speaking of this comparison, it's very hard to compare things, but I mean, in some sense I found, as I said, his paper easy to read. For example, the way I figure out how to understand Langlands' classification of representation for real groups, I have to read it backwards. And in the back, there is a harmonic analysis, and there are induced representations. And in a way, when I was reading the beginning, because I knew none of number theory. I just couldn't understand where this leads. When I
was
read
writing
the end,
about
then I understood.
this paper once. I said that representation theorists have to start in section 3.
Yes.
I think that one way that these gods of mathematics differ is in how they interact with other people. And Harish-Chandra was certainly extremely open to other people and to talking to other people and to learning from other people, but his actual work was, I think, largely a solitary endeavor, that he did things by himself. And this is quite different with other people. I think Borel had a large number of peers, people that he collaborated with as equals. Langlands had a large army of serfs, people that he told what to do and guided their development of what he was, and that's one aspect of different ways of doing mathematics.
You said that Harish-Chandra said that for some people, some things are easy, but for some other people, some other things are simple. So, in that, going a little further, does he have opinions about quotations attributed to the people? God does not play dice, things like that. Does he have a differing opinion on such things?
No. See, I can't be sure, but the first part was entirely algebraic. The second part was analysis, essentially, and the lemma. And probably he was pointing out that Borel is not as comfortable in analysis as with algebra. This is possibly the thrust of his remark. As a matter of fact, the first part was algebra, and many people in the audience, including me, for instance, knew that. The second part, certainly, many of us had no idea how we would go about proving it. This is, I'm also in the same Bourbaki kind of people who know a lot more algebra than who are comfortable, not comfortable with analysis. So that's what I think was the reason for his remark.
There's something you can notice on the whole series of papers, actually, leading in particular to the discrete series and the Plancherel formula, And actually, this is not a remark of mine, it's a remark of Langland's, I can't remember where. It's that at the time of his first papers, as you mentioned, the center of the enveloping algebra in particular, the construction of the algebras and the representations. Actually, this is the part that you might characterize as near Bourbaki. It's abstract algebra, and he does it very well. And then after a while, after writing preliminary papers on SL2R, then he embarks on the general task of understanding representations of semi-simple groups. And what Langland's remarks, and okay, at some point, clearly he assimilated some of the recent techniques of the mathematics of his time. So I can't believe that he did not understand sheaves, for example, and certainly he understood distributions and so on. But from then on, and again, that's what Langland says, and I think it's correct, his papers are a concatenation of very ingenious, difficult, elementary mathematics.
Right.
There are no new big techniques. For example, regular singularities. I suppose if Harish-Chandra had wanted to understand that in several variables, he could have done that as well as Deligne. But no, he's always sticking with methods which are essentially elementary.
I think that's it's again because of his early training as a physicist, not a mathematician. So he had to reinvent all the algebra which was the mathematician, many graduate students will be familiar with. He had to reinvent all that, but it gave him no problem. He reinvented and went along. I remember, I was trying to read his early papers, the transactions, represents on a Banach space of the Lie group, and it's all algebraic completely. I mean, he had transformed the representation, the problems to pure algebra, and was handling it as any algebraist would, and maybe with greater mastery than most algebraists.
Yeah, so also this is very clear on the papers on local integrability. You see, you have this notion of radial part. I find it hard to believe that it did not occur elsewhere, possibly before, because it's such a natural thing. But he does everything from scratch.
Right. No, when I was reading these papers, I could find, because of this fact that he was on the spot proving many theorems, many results which were kind of known. So I could simplify some proofs. And I very foolishly mentioned that I could do this to, of all people, Whale. And Whale said, local simplifications are always possible. They are irrelevant.
There's a standard story in computer programming that any moderately complicated program can be shortened by one line, and any moderately complicated program has a bug. And a mathematician immediately makes an inductive argument to conclude that any program can be reduced to a single line, which is wrong.
There is this, it's often said that there are mathematicians of two kinds, those who are problem solvers and those who build theories. Obviously, the line between the two is not very clear, but where will you place Harish-Chandra?
He created the theory of Lie groups from the beginning to the end. So in some sense, he created the theory and he had a problem in mind and he solved that.
Right, sure. I mean, very often, creators of theory, there are other people picking up the theory and working on it. But here, it seems he built a theory and before anybody else could get into it, he was finishing it. That is what is happening.
Well, we can consider p-adic groups later, but for real groups, he is really a problem solver because, of course, the physicists, Bargmann, Wigner, had considered unitary representations of semi-simple groups first. I mean, it comes from quantum mechanics, obviously. The obvious notions are obvious. I mean, if you work in the unitary category, you have a Hilbert space, you have an action, you want it to be irreducible. Not only are they obvious, but they are actually often the good notions in physics, right? So the problem was posed. And in fact, the abstract part was done by Mackie, Godman, and so on. So you had an abstract theory for locally compact groups. And then the problem was to understand all those representations for an arbitrary semi-simple group, say. And that's a problem in problem solving. The foundations are laid out. The really theoretical notion is, of course, the notion that we saw of a GK module. But first of all, it's already essentially in Bargman for SL2. And for Harish-Chandra, this was obvious. This was easy, I think. And after that, he goes on and he solves all the problems. That's the way I see it.
I think, you know, in fairness to another mathematician for whom Harish-Chandra had great admiration, I believe that Harish-Chandra attributes essentially the ideas about GK modules to suggestions from Chevalley, that Harish-Chandra knew very well that he needed to find a way to study unitary representations algebraically, and it was Chevalley who pushed him into things like, well, you should study not only unitary representations, but some more general class. But I agree with all these ideas that this is problem solving, that he did see from physics that unitary group representations had a fundamental role to play in describing the universe. And therefore, it was an interesting part of God's list to work out how they worked.
In fact, I was looking at some of his early papers, and I do notice that he thanks Chevalley for several of the early papers.
But in the first part of his mathematics, well, it's not the first part, but the part we were talking about, where he was proving algebraic theorems, he was very close to Chevalley. In fact, they were both in Columbia, I think. And
they were both in Columbia.
So
yes,
the communication, if not the influence, is obvious. But then after that, he goes to the wide world of unitary representations.
He's also similar to Chevalley in the sense, Chevalley was a very austere person, and so was Harish-Chandra.
Was it Chevalley? You know, there is some incident where Harish-Chandra was in the lecture. Probably it was Chevalley who was lecturing. So he writes something, but then he is not able to completely prove it, and then he hides the board and tries to scribble, and then finally announces that, I think this is true, but right now I do not know how to prove it. But Harish-Chandra then says that to somebody afterwards, maybe to Mosto, how can someone be sure about not able, without being able to prove it?
Well, okay, my take is I think there were lots of people working on the representation theory of Lie groups, like physicists and others, who were often working with specific examples. And then there were other people who were working on very general things like locally compact groups of type 1. And then their representation theory, they would prove results about general, integral decomposition and all that. But Harish-Chandra, to me, emphasized, if not, I don't know if he was the first to realize, emphasized working with semi-simple algebraic groups because he could use all the structure theory. He wanted to do analysis on semi-simple groups, but he wanted to be in a context where there was a lot of algebraic structure he could use.
It was very important that you can make a precise model of a semi-simple group in C++, whereas for a solvable group, it's not possible.
Right, yeah.
By the way, contrary to some things which have been said, there is at least one paper of Harish-Chandra where he says, I quote, "I believe this to be true, but do not have a proof."
Is that theorem? Rank G equals rank K? No, on the second board.
Yeah. No, this is the paper on the submersion principle for p-adic groups.
But I think he wouldn't give a lecture saying, I've proved this theorem, and I don't remember the proof. But there are people who do that, and that's what he was complaining about, that there are people who claim, oh, it's almost there, so it's a theorem, but then they haven't checked all the details. So, I don't know. I think he was very much an ascetic in that sense. I should confess, I only knew him in the last year of his life, so I don't know.
I think this theorem about discrete series came up only in 65, 66, but I'm certain that he would have announced it long time ago. Or he would have anticipated it, I would imagine, in late 50s.
Well, of course, William Stone is also just announcements. There are no proofs in a sense. So, yeah, he did announce things before, yes.
William Stone for p-adic groups, the submersion principle.
Is it p-adic groups or
Williamstown is 72, 73.
72.
72.
But Helgeson says that though Harish-Chandra attended that summer school in Williamstown, he did not lecture there, but he
Perhaps
lectured
he
on-
was not well.
I don't know.
I think V.S. Varadarajan spoke for him. I have the feeling, and it is there in the 5th collected works, that in fact this collected work has many exchange of letters, and I think they are very, I think they give insight about how Harish-Chandra thought about various things, not only about mathematics, but also about various other things.
Correspondence between who?
Harish-Chandra and V.S. Varadarajan mostly, but I think there are some other letters also.
Varadarajan, of course, hero worshipped.
No, but there are letters from, I think these letters are only from Harish-Chandra to Varadarajan. Okay. And they talk about many matters.
But he wasn't well.
Sorry?
He wasn't well
Yes,
then.
so I think I did read in one of those letters
That's
that he
correct.
was not well, and I think he may have sent Varadarajan some written notes about what the topics are, and he is very thankful to Varadarajan to have done a great job.
I think later Harish-Chandra was to lecture in Canada somewhere, but he asked Varadarajan to go and
famous. Ottawa lectures.
Okay, he asked Varadarajan to go and lecture. Varadarajan, after the lectures, came back and told Harish-Chandra that when I started, the hall was half full, but towards the end, it was less than 1/4. And Harish-Chandra told him that, well, if I had gone there, it would have started with 1/4 and maybe 2 or 3 people left.
In the early papers, he always more or less started with, we fix the square root of -1, call it I, and so on. V.S. Varadarajan did it in one paper. Okay, and M.S. Narasimhan once asked Varadarajan, do you fix the same square root of -1 as Harish-Chandra, or is it different? I don't think it happened. The early papers had this fixing square root of -1, but later papers I don't think do that.
They stay fixed.
Sorry?
They stay fixed after some point.
As in the previous paper. I think he continues his works referring to his earlier works. So I think there is, I think in the olden days it must have been difficult to read him because the papers are not together and he will refer back.
Yeah, you have notation and carries forward.
Carries forward and...
yeah, now you can just have a bunch of windows open in your browser, but in those days you had 15 volumes sitting on the damn table. It was awful.
No, but this question, which square root of -1, seems to be very relevant because if you consider complex of sheaves on, the perverse sheaves for 1 square root -1, if you had fixed another square root of -1, the perverse sheaves will still be perverse sheaves, but they may not be identical.
I mean, it's a serious point in interpreting the Fourier transform and the actual formulas for Fourier transforms that, it just reverses the meaning of a lot of things if you change the I. I'm sure that there was some issue that he was concerned about, that he was fixing in his mind by this choice.
About these perverse sheaves, I asked Hota the question whether, and what is the corresponding D module, the holonomic D module in the Riemann-Hilbert correspondence, that is on the right side, fix another square root of -1, you get a different perverse sheaf. But then Hota, when he went back, he asked Kashiwara, and Kashiwara published a paper on this.
Something that surprised me about Harish-Chandra, I was wondering if other people have opinions. Like, I heard that in his important work on discrete series and things were happening, he would announce more or less a theorem that he wanted to prove at the end of the year, and then he would start lecturing. And it actually sounded scary to me to do that, actually. And apparently he did it many times, repeatedly, and Paul Sally told me he would travel to those lectures, and so did so many other people. But Paul Talley said once that, I said, did he always prove what he wanted to at the end? And Paul said, no. But typically, if he didn't prove them, he had some health issue, like a heart attack or something.
I mean,
that
I
actually
think
scared me like quite a bit. Like,
it wasn't just that he intended to work really hard on this. I think he could hold very complicated arguments in his mind. And when he set out saying that he was going to do this, I think that he knew in great detail what he had to do, and that on a few occasions his health prevented him from completing it, but it wasn't the lack of a complete proof in his mind.
Yeah, I mean, I have seen the notes from in 74, 75, and he lectured on Plancherel theorem, and it was clear that he's lecturing to check with the audience that all the arguments are complete, that nobody has any complaints, because when you compare this with later papers, these are exactly the same arguments, maybe a little bit changed and polished, but I think this was more of that he tried to convince himself that all the details are in. I think even he mentioned once to me that he's giving this talk more for himself than for the audience.
I can't comment directly, of course, on this, but I had a discussion with Michael Attia, who is another family friend, and he told me, half in jest, that whenever he heard that my father was sick, the first question he asked was, what is he working on? Because he usually got sick when it was very intense. And maybe he found a mistake in his proof or something.
Something got stuck.
And something got stuck and it just didn't work according to plan. And then he had the ability to just keep the intensity going up until a sort of metaphorical fuse just said, no more. And so that's what tended to happen.
I would like to partially correct what I said about this chain of elementary arguments in Harish-Chandra's work. I still believe that's true because it's said somewhere by Langlands. But on the other hand, there is also a series of discoveries, discoveries of really important objects in the field. So, for example, one thing which I find miraculous is the Schwarz space. I mean, the Harish-Chandra Schwarz space. The Schwarz's Schwarz space, actually, where his priorities are often discussed, that's not interesting. The point is that it's totally natural, okay? If you think of a good space for the Fourier transform, hard enough you will get the Schwarz space. But Harish-Chandra's Schwarz space, with the intervention of the trivial spherical function in the equation, and that works everywhere, and it gives you exactly the tempered representations. This is a miracle, and it takes a lot of...
completely nothing like that in harmonic analysis before.
It takes a lot of insight to find the extra argument which exactly compensates for the negative curvature of the group and so on. It's exactly what it takes. And of course, there are several other things. For example, Harish-Chandra descent. Okay, we don't think about it. For us, it's so obvious, either on the side of the characters or on the side of the orbital integrals. It's just the thing to do. But I mean, you just have to have the idea of doing it, even if you have found that it came from natural computations for SL2R. And I think actually it would be of interest to isolate maybe 10 or 15 contributions of this kind, which are technical. I mean, this is not a theory, but it plays a central role when you want to develop the whole theory that he did develop. And then it's the same, of course, for p-adic groups. And then the constant term comes in when we do p-adic representations of p-adic groups and so on. So there are a whole series of contributions which now, of course, are just accepted and assimilated by everybody.
Yeah, actually, I needed the slight refinement of these results with Schwartz space when you have a more rapid growth and also weaker growth to do this estimates for discrete series. So I went through his proofs in minute details to try to steal his ideas. And I mean, there was one ingenious trick after another. And so the intuition was just unbelievable that he just figured out the right trick to get right inequality and right property.
He told a story about mathematical induction once. He says it's like getting a bank loan to start a business, that if you don't borrow enough money, then you don't have enough capital to start your business and it fails. If you borrow too much money, then you can't make the payments and you go under too. The key for an inductive proof is to make exactly the right level of inductive hypothesis. And his papers are just all like that. Yeah, it's just an inductive argument, but it's exactly the right inductive argument, and it isn't at all obvious what exactly the right argument was.
Anybody has anything more to say?
I just wanted to double check, about his working styles. I heard a story that Harish-Chandra and they had invited some colleagues for dinner. And people came and they ate and it was going on. But at some appointed time, like 9:30 or 10, he left the party telling his wife that now you take over, and he went back to his study.
Well, actually, it sometimes got more than that.
Oh, okay.
When my father was set on his ideas, nothing could stop him. So we often had, but I have to say, he was rude, but democratically rude. It could be very senior people, it could be graduate students, when he was on his ideas. So I remember a time, so we lived with my grandmother as well, and my mother was very busy taking care of us and also my grandmother. So I remember that Pierre de Ligne came to visit. He was very young. He had just proved one of Grothendieck's conjectures. And he came to see my father. And it was like, I forget what, 2 p.m. And he came over in his very shy, sweet self. He's wonderful. And he came to see my father. And so my mother, of course, offered him some tea. But he had something he really wanted to say to my father.
Wanted to ask him what's a C function.
Maybe. But my father, he was burning hot. He wanted to go back. He had come down for his tea. Maybe it was 3:00. He had come down for his tea, but he wasn't planning to have a long discussion with Pierre de Ligne. And my grandmother was having her own thing. So, and there was I, a high school senior. I had exams the next day, actually a physics exam. And my mother just told me, here's Pierre de Ligne, take him around Princeton, come home for dinner at 7:30. So there I was with Pierre de Ligne. And I did this many times with mathematicians. I had known Pierre de Ligne from our sabbatical in Bure, so I knew him a little bit. Of course, I practiced for my exam with Pierre. I told him what was going to be on my exam. I talked to him. I showed him the sights of Princeton. It takes, for those of you who know Princeton, stretching it out to, 4.5 hours takes a certain amount. We had a winding number. We were going around and around. But I had been a tour guide for Princeton University, so I knew the sights, and Pierre was of course, very charming. And at 7:30, I showed up, and we had dinner. But that's the way my father was. That's when he was working, nothing got in the way. And so we were just used to it. And so, this is how I grew up. And no one said, oh, she has an exam, whatever. Forget it. This came first. But I'm just saying that...
And you entertained Pierre.
Yeah, but I also entertained graduate students who came too. I'm just giving the example that at least he was democratically rude. It wasn't just to, if he was
young member,
if
young
he was,
visiting members.
The point was, if he had a set idea of how he wanted to spend the day, that was it. So yes, I can fully believe that. He often would come down, eat. He would be very interactive, but then he would go up, and that was standard operating procedure.
Did he work mostly at home or?
Yes, yes. I think he felt the institute was quite competitive. There were a lot of competitive people, and I think he felt better working at home. So as a result, we had to tiptoe around the house because his study was on upstairs, and we had to be very careful not to make much noise. I didn't know anything about rock music. We didn't know about headphones, so we didn't know anything about rock music. I could practice piano. If it was really bad, he asked me to stop. We had to tune the piano. My sister played her flute, but we were tiptoeing around a lot. He went in for any kind of committee meeting. I'm sure he did whatever he had to, but yes, he worked at home.
Maybe the audience want to ask questions or make their own comments.
Yeah, I wanted to ask, how was his relation with Gelfand and Gleason?
Well, I only know from a child's perspective. The one I know about Gelfand. Did you ask about Gleason?
No, Constant.
Oh, Constant. Okay, I thought you said Gleason. My father didn't do pleasantries like holidays and birthdays that just interrupted his work. But he had tremendous respect for Gelfand. And once a year, a New Year's card would come in Russian from Gelfand. And my grandmother, who was Polish, would translate it, and then a return card would go. And my father was very particular about what had to be written in Russian in the card. And so, the fact that they exchanged this every year was, and that was the only person he ever wrote a New Year's card to. So he had the highest respect for Gelfand.
So I'm sorry, he didn't read even mathematical Russian?
He did read mathematical Russian,
okay.
but I think on a New Year's card he needed my grandmother's help.
In a script also.
But my grandmother helped that. But he had learned from my grandmother French, German, and Russian.
Yes, because mathematicians.
And he could read Russian papers, but the honest truth was that he always joked he had an in-house translator. So, for example, he knew about Gelfand's papers before they were translated because he could read the mathematics, and then when he had questions, he went to my grandmother. And so she would translate for him.
But mathematicians at that time read Russian. Goldman, for example, he read the papers.
So, I think for the most part he could get it, but sometimes he would ask for a word or two. But he had taken Russian with her exactly for this reason. But I remember when papers from Gelfand would arrive, then my grandmother would be called into action. But yes, go ahead.
I think we'll close this session. Thank you all.